Hello friends, welcome to Awdhesh Academy. We are on real numbers and this is our last video lesson of this topic. Today we are going to discuss about the irrational numbers. Let's quickly recap what is an irrational number. An irrational number is a number which cannot be represented in the form of p by q, where p and q are co-prime and q is not equal to 0. Also, we have seen in the earlier video lesson of decimal expansions of real numbers that an irrational number has a decimal expansion which is non-terminating and non-repeating in nature. Now, in this lesson, we are going to discuss how to prove that a number is an irrational number. Before going to that, we need to understand two very important concepts. The first is a theorem which says that let p be a prime number if p divides a square, then p divides a, where a is a positive integer. Now, let's take 5 as an example. 5 is a prime number and 100, which is 10 square, is a multiple of 5. Now, 5 divides 100 as well as its root, that is 10. So, if 5 divides 100 and 5 also divides 10. So, this is the theorem. Now, before moving on to proving that a certain number is irrational, we have to know a very interesting concept of proving by contradiction. Here, we first assume the exact contrary of the given premise we have to prove. Then, we process the left hand side and right hand side in such a way that at the end, the two sides will contradict each other. And then we will conclude that our initial assumption of taking the contrary of the given premise was wrong and thus the premise is correct. Now, let's move on to solving some questions. Let's take the first question. It says, prove that root 2 is irrational. Now, we will solve this using the proof by contradiction method which I just told you about. So, let's assume the contrary of the premise we have to prove, that is, let root 2 be rational. Now, we know that a rational number is a number which can be represented in the form of p by q. So, let's assume root 2 as a by b, where a and b are co-prime. That is, they do not have any other factor common between them apart from 1. Now, let's cross multiply them. So, we get a equals root 2 b. Now, squaring both sides, we get a square equals 2b square. So, we get 2 divides a square. Since here we see that a square is of the form 2 into something, that means we can say that 2 divides a square or a square is divisible by 2. In the beginning of the lesson, I told you about the theorem which stated that if a prime number divides a certain number a square, then that prime number will divide a as well. So, we can say that if 2 divides a square, then 2 will divide a as well. Now, let this be our first equation. Now, from this we can write a as 2c, where c is some integer. Now, we can substitute this value of a in this equation and we will get a square equals 4c square is equal to 2b square. Now, we will just take this part of the equation . We can cancel the 2 and we get b square is equal to 2c square. Now, here we see that b square is 2 into something, that means we can say that 2 divides b square. Now, again using that theorem, we can say that 2 divides b as well. Now let this be 2. Now look at 1 where we proved that 2 divides a, and here we are proving that 2 divides b. This is in contradiction to our first assumption where we had said that a and b are co-prime, that is, they do not have any other factor apart from 1 in common. So we can say that our initial assumption of taking root 2 as rational was wrong, thus root 2 is irrational. One more thing, this proof will be same for any other number which is a square root of a prime number. Let's say for root 3, root 5, root 7, root p, this entire method would be the same. In the first question, we had proven that root 2 is an irrational number, and I told you that in the similar way we can prove that root of any other prime number is an irrational number. Now in the second type of questions in this lesson, we'll directly take the results like in the first question, that is, say root 2, root 3, root 5, root 7 are irrational, directly into our questions. So let's take one question as an example. Let's say we have to prove that 5 minus root 3 is an irrational number. Now we'll again prove this by the method of contradiction. So first let 5 minus root 3 be rational. So 5 minus root 3 can be written as a by b, where a and b are integers and are co-prime to each other. Now here let's bring the a by b on the left hand side. So we get 5 minus a by b equals root 3. Now we'll take the LCM and we'll get 5b minus a is equal to root 3. Now in the left hand side we see that since a is an integer, b is an integer, this left hand side is rational. Since left hand side is equal to the right hand side, thus we will get the RHS as also rational. Now we know that root 3 is irrational. We don't have to prove this again, but we can use the result directly. So we'll write, since we know that root 3 is irrational, so we can say that there is a contradiction and left hand side is not equal to right hand side, thus our assumption was wrong. Thus 5 minus root 3 is irrational. Now in these type of questions, no matter what expression is given to you, all you have to do is assume it to be a by b and then take all the rational part on one side and the irrational part on the other side. Now the entire procedure will be same given any other expression to be proven as irrational. All you have to do is let that expression be rational, then you will represent it in the form of a by b, and then this step, that is what you have to do here is put the irrational part on one side and all the rational part on one side. Like suppose you had 5 root 3 instead of 5 minus root 3, so you will first let it be a by b and then you will let the root part be here, that is the irrational part on one side, and take the 5 on other side. So we will get root 3 equals a by 5b. Now you will say that a, b and 5 are all integers, so the right hand side is rational So root 3 must be rational. But since we know that root 3 is not rational or is an irrational number, thus we'll say that our assumption was wrong, there is a contradiction, and thus whatever expression is given to you is irrational. That's it in this video. So today we have learned about irrational numbers in detail and also how to prove that a certain number is irrational. Take the test at the website and revise your concepts again. Thank you for watching the video. Goodbye.